हाँ पिला रहे हैं। तो चाय देखो।
So good evening to all people who have joined this today's webinar of the AE Kolkata chapter of ISWBM. So the welcome to the AE ISWBM Kolkata chapter. So the first chapter of the Association of Energy Engineers. The Association of Energy Engineers is a renowned body of energy professionals with over 147 chapters over the globe, including 70 in the US and 77 in other countries. So the first chapter of AEE was launched in India on February 21, 2003 by Mr. George N. Sibley, the American Consulate General of USA in Kolkata at our prestigious institute ISWBM. This facilitates the senior managers in energy intensive industries in the region to share with the US counterparts on state of the art technology and practices in energy management. The AEE ISWM Kolkata chapter boasts of securing the international awards during the last 18 years, since the year of its inception in 2003. The chapter has been adjudged with award of various categories like Best Chapter website, Best Student Chapter, Best Community Service, and Best Chapter Newsletter. The chapter has also received Best Overall Chapter Performance Award in the year 2005, 2009, 2010, 2014, 2015, and 2018. Most recently, 5 students from our Energy Management Department have received the prestigious AEE International Scholarships this year. So this further adds to our achievements. So coming back to today's webinar, the topic for today's webinar is carbon reduction, a Western approach. And we have with us our two most distinguished speakers, Mr. John Amatruda and Mr. Devashish Lahiri, who both have been principals at Socotec USA LPI. John Amatruda is the principal of Green Services at Socotec USA. He has over 35 years of professional experience and specializes in environmentally conscious design and the evaluation of green materials and systems. John has worked as a consultant on over 100 LED projects nationwide and internationally, using all variations of the LEED commercial program. He has also authored a number of green building studies and publications, including the GSA LEED cost study for the US General Services Administration, the NYC Department of Buildings Energy Code compliance study, and the green material selection guidelines for the web-based whole building design guide. Mr. Amatruda has been a LEED accredited professional since 2001 and was the first LEED AP registered in the state of Connecticut. He was also one of the first 30 faculty members hired by the USGBC and was named a LEED Fellow in 2013. He is additionally accredited as an assessor under the United Kingdom's BREEAM Green Building Rating System. Mr. Devashish Lahiri, on the other hand, is a subject matter expert on areas related to ASHRAE level 1, 2, 3 audits and energy efficiency, field monitoring and troubleshooting and assessment, measurement and verification, blower door and air infiltration, odor migration and condensation on framing, lead commissioning, monitoring based commissioning various NYC local laws such as Local Law 84, 87 and 97 of NYC DOB, cogeneration service water systems, energy storage, and renewable energy. He has also worked on retro commissioning, continuous commissioning, building management system verification, balancing troubleshooting in energy recovery, etc. in steam and chilled water systems, steam absorption and chiller troubleshooting. So the topic that both of our distinguished experts will discuss upon today is carbon reduction, a Western approach. In today's world, I don't think something is as relevant as this topic, since we all know that there are COP conferences every year, and obviously in today's world, sustainability is a major issue. We are all hell bent upon reducing the amount of carbon dioxide that we are continuously emitting into the atmosphere, simply because climate change is occurring, global warming is occurring, and the entire existence of our race is at stake if we don't control this continuous emission of carbon dioxide into our atmosphere. So carbon reduction is very critical and it's very complex, since every activity that a human being does releases carbon. You name any sector, be it transportation, be it building construction, be it simple day-to-day activities, there are carbon emissions and we need to manage them. And what makes it more complex is that there are many indirect emissions which are come under the scope 3 emissions that sometimes go unnoticed or unmeasured. So this is an extremely critical and issue that our world faces today. And we know that each year United Nations conducts this COP, and nations meet there to discuss how we can reduce these carbon emissions and achieve the sustainable development goals, all for a net zero world. So to keeping all this in mind, this topic for today will be carbon reduction and Western approach. And our both of our speakers will try to enlighten us in the ways in which this carbon reduction can be achieved, so that we can all achieve a net zero world, and we can all achieve this within our deadline. So finally, I would like to give my heartiest welcome to both our speakers, and I would like to thank them for kindly consenting to grace today's occasion. And I hope this will be extremely enthralling and enlightening session. So over to you, sir. Over to both of you, sirs. The stage is all yours now. Thank you.
So good evening, everyone.
Good evening, sir.
I'm not sure if you can hear us clear.
Yeah, sir. We can hear you absolutely clearly.
Okay. So I'll first take this opportunity to thank ISWBM for arranging this, and also would like to thank the students who are present in this meeting on a Saturday evening. I can imagine what you could have done in this hour when we were students. And the subject is important. I think it's important for your career and for our society at large. And I'd also like to take a minute to review the presentation. So in the very beginning, we'd like to present through these two portions. We just heard from Vaibhav that the scope 1, 2, 3, but this one in specific will focus on operational carbon and embodied carbon. And those two carbon management, I'm not sure if you can see the share. Are you all able to see the share?
I know. I think the sharing has stopped. Can you reshare it?
I can share, but I don't know if it is sharing.
Yes. Now it's okay. Now it's visible.
Okay. So what I was saying, that we will first begin with the operational carbon in buildings, and then the embodied carbon will be covered by John. And I would like to thank John to jump in on a Saturday morning here. And at the end, we will discuss a little bit, which is of the utmost importance for the students, that is the careers where they can find opportunities. So if you are all ready, we can begin. We have about 50 minutes left. So my first opening slide, and you can see this progression of the slides. I did try a video, but it did not work, and it will not work through Zoom. Our ideas related to buildings and construction sectors on COP 26 and 27, you are aware of that, and it was presented by the United Nations. You can see it online, those summary sectors, but there is a large push for 2050 decarbonization. But at the same time, we are all aware that we are not on track. The reality is somewhere much later, and it will depend on multiple key nations, multiple key practices. We are part of the buildings, and the building sector where we practice will have some impact, but that's not all. So let's quickly review the background. It is important for everyone to understand the global picture first. I always start with that approach so that we all feel that we are at a base where we can build upon. So this one gives a very summarized picture, a top-level picture of where the world energy usage is by the fuel type. And in our lifetime, if you look from the left to the right, you can see the improvement, increase in the usage. You can see the consumption pattern, and you can also see that how the world, Asia, and particularly China, from the last 20 years have used energy. And of the 150 or 140 terawatt hours, Asia is a large consumer. China is half of Asia, and United States is about 15% of the world flat, you know. So there have been this, as Baiva was saying, that John had been the lead, the U.S. Green Building Council's first instructor, or one of the initial instructors. He has been teaching this since 20 years. And you can see right on the screen that at the bottom left, that the United States is trying to hold the total energy consumption, and the idea is to bring it down. This is fossil fuel. And if you now get to a little different chart, the world remains same, Asia remains same. The China is 30, India is about 8 terawatt hours on the right top, but it is increasing at a faster clip than China. So China's very last 2 years is a little bit flatter, and India's usage is going higher. So students from that area should focus. And we see every day on even international news here that the indoor air quality is lower, and indoor air quality is almost dangerous in certain cities in India. It is shown. The next one, look at the carbon emissions. The previous one was about fuel consumption. So what are these fuels produce? As they are burned or used for industrial activities, they produce carbon. And this one is a chart where we can get some idea that how different economies are contributing to the carbon. And if you go to COP26 or 27, these have been discussed. I don't have the animation, but if you push the next 20 years, this China's and India's numbers are going to change, because India is putting more coal in their power plants. They are increasing emissions and industrializing at a more rapid pace. US will remain very similar. The whole pie, the round shape, will increase and become bigger. Now
Devda,
come to the buildings.
Devda,
Yes.
hello. Would you
Yes.
mind showing in full screen F5? Maybe better, or as you like.
I can try full screen. If that's easier.
Yes, yes. Yeah.
Okay. So we were at the screen, we were saying, things will change. The percentage will increase for India, decrease for China. But at the same time, we have to all work towards bringing it down. So coming back to the global share of buildings, what are the global share of operational carbon, because I'm working on the operational side. Let's take a quick look. On the right-hand side, we are 37% of the operational carbon. And of that, what are the residential, non-residential. So you can use some of these data to make yourself aware of where you can contribute or practice as you graduate. Opportunities in the building sector is huge, and that's where we practice. And this one is the global climate tracker. If you look at the right side of the chart, you know, whole idea on the left is to continue going right 2050. But if we don't do anything, do nothing case, it will not move the target. So, and on the right, it's a zoomed version because of pandemic. Yes, it did try to track better, but again, we became off track. So zero carbon target, you know, many of you probably are into this World Cup cricket and you follow this run rate, and this is very, very similar. So this is simply saying that how can you track our decarbonization rate to meet our goal? And as one of these individual bubbles show, that as we pass through different events, as wickets fall, we are either closer or at a higher distance from our target. Now, net zero, Vaibhav also presented. If you look, buildings, the power sector emits a whole lot because of the use of coal in generating power. Transport, we are doing some electrification. Buildings, not so much, but still it is a significant number. And this one will be discussed a little bit more. I did not have time to research this, but the net zero can be a different seminar or different discussion. Today's discussion, we are focusing on decarbonization, or rather operational carbon in buildings. Now, operational carbon, if you look at what AEE is saying, you're all members of AEE, or at least part of this AEE seminar, you will see that waste reduction, that is energy efficiency, is at the top. You have to first, if you want to save money, if you want to save energy, the first thing is to stop wastage. And there are many ways. You probably, I don't have to repeat, you have learned it in class, you have seen it in your projects, you have seen it in actual buildings, through audits, and then propose these low carbon solutions. And the low carbon solutions are many, some are hyped, and the jury is out there whether this technology of heat pump, this technology of grid being a green grid, will happen in 30 years or 50 years. It will happen eventually. It has to, because it's a matter of survival. We just can't let CO2 take us down. But in this process, there is also this item number 3, because collaboration and transparency between nations, between agencies, between certain elements of what I would say, the building sector, the transportation sector, all of that artificial intelligence and all of that data usage are being constantly forming various partnerships. They are the people who are using the data, people who are generating the data, people who are analyzing the data are always collaborating. So between the academics and the policymakers and the industry, this constant circle is revolving to get us there. So AEE has produced a lot of white papers. I'm sure you have produced many research papers in your institute. But at the practice level, individually as humans and as a society and as a nation, we all have to go towards that same goal. Now, if you're in a new building, I'll just give some pointers. Focus, in planning and design. That is the biggest impact you can make. Work for low energy buildings. There are certain guidelines in our definitions of what a low energy building should be, how many kWh per square foot, or how many joules per square foot, kilojoules per square foot per year, and then working on the infrastructure, reducing losses, making sure the grid has inputs from renewable sources, and policy. But if you think a little deeper, existing buildings are the bigger issues, because at least in the Western countries, because we are trying to share what we have learned, that a large stock of these buildings will remain next 50 years. They're built for 100 years. So we will have to focus on these existing buildings as well. You cannot ignore and assume that you will reach the goal. You can legislate saying we cannot have cars in the street who are 10 years or older. You can scrap them and buy new cars. But buildings are where people live. You cannot simply demolish and rebuild. So existing buildings offer a lot of opportunities. That's an area of practice in my department. And we all know, again, these lists, but nonetheless, many of these will become more relevant in the Indian context, particularly the cooling and ventilation. I was discussing with Dr. Chaudhary, Binay Chaudhary, who is from my school. And then we were, and as bigger buildings and high-rise come in, you will see impact of elevators, impact of vertical transportation. As people are more affluent, you will see appliances take a larger part of your energy pie. And eventually controls, but of all these things, the controls are the key, because as you have seen in your phone in the pocket, has more processing power than a PC 10 years back. So we have fantastic building controls with real-time energy management work. In every building, you can use some form of a feedback control. Every building, you can use some form of a strategy to allow the building operator to work more efficiently. And in addition, we are working with large universities here who are thinking of adaptive controls, that is, students moving from one class to another class. The professors have ability to book a class just like a hotel, and until 10 minutes before the class begins, that room is not air conditioned. Until 5 minutes when the class begins, the rooms do not have lighting. They all have a safety lighting. They all have air conditioning to a base, which we call setback. But the major chillers or the major split units will be all connected to an internet-based system. They're called addressable systems. And the building manager can program it, and the professors can request their classes based on schedule, and it will be followed. Now, career opportunities will come to the last part. I'll stop here, stop my share, and discuss it after John presents his section. So very briefly, we discussed on these last three things, how to decarbonize new buildings, existing buildings, and what is the most potent tool in our hand. You cannot manufacture an equipment, but you can control it. Always keep that in mind, that controls is like your nervous system. What you're thinking, based on that, your limbs and hands and legs will be responding. So I'll stop here and we'll come back to this screen for career opportunities once John is over. Thank you for listening.
Thanks, Dave. Oops. Get mine going here. Can everyone see that?
Yes, it's visible.
Thank you. So as Dave mentioned, I'm actually an architect by training, and I've been a sustainability consultant for really over 30 years now. And I am going to talk about embodied carbon strategies for buildings as a sort of a complement to what Dave was talking about. Embodied carbon is an area which, while there's been research into this issue for quite a number of years, it's really just starting, I would say, to become a major factor in the decarbonization strategies that are being considered, and they're really starting to have a direct impact in various ways with building designers and operators to become part of their strategy in terms of how to ultimately address and try to meet those decarbonization goals that Dave was talking about at the very beginning. So I'm going to talk more about, some direct actions and tools and things that we actually use in the West to evaluate and to work with embodied carbon and embodied carbon reductions. I'm just going to start off here by just showing a basic slide for those of you who may be less familiar. When we talk about embodied carbon, we're talking about the energy and emissions that are in fact associated with the actual construction of the buildings themselves and the associated materials. It's a process that has been very well defined these days in terms of process, from really looking at the whole life cycle of a material, from the extraction of raw materials you see here in the categories or the stages that are called A, through manufacturing, transportation, and actual construction of a project. Looking at use impacts related primarily to renovations and operations and maintenance factors for replacements of materials, and then ultimately either through material disposal or through potential recycling and reuse of materials within a building. A lot of the focus these days, although this whole life cycle is really important, but in terms of doing evaluations, particularly for new buildings, mostly these stage A impacts are what a lot of the tools focus on. And so why is this issue becoming more important? Operational energy, as we know, has been a key focus on buildings for quite a few years. But if you look at the big picture of this pie chart, even though operation energy is very significant in terms of buildings, the production and of building materials is still very significant. It is about 11% of the total carbon and energy impact associated with various activities. If you look to this table over to the right, what you tend to see is that while we are typically when we talk about operational energy, which is what you see in the green and the blue part of the chart, that's obviously an ongoing thing that you look at on a yearly basis. There are these major spikes in carbon that are associated. Obviously, the biggest one is with the construction of a building, if it's a brand new building, and then you typically have these cycles over 15 years or so with major renovation work that happens as well. When you start to add these factors in for the embodied carbon for over that building life cycle, they start to add up to be something fairly significant over the life of the building. And also what you tend to find is, while, as Dave mentioned earlier, while there's a lot of effort, as you probably know, to try to decarbonize the electricity grid and therefore make that impacts from the operational energy go down, both in terms of energy efficiency and in terms of using increased renewables. What you tend to see in the industry that produces materials is that reduction tends to happen slower, and therefore those spikes, particularly at the beginning when you're talking about building a new building now, tend to be fairly significant, and they are very high in terms of fossil fuel use and therefore the emissions that they produce. So trying to find strategies to reduce that embodied carbon is very significant. And of course, also we see in developing countries that as their economies continue to grow, that the amount of material associated with that growth is very significant. And and at the same time that we're trying to hit net zero goals by 2050, we see that the potential additional emissions from the increased use of materials for growth and development could double by 2060. So that creates an additional challenge that has to be addressed when we talk about embodied carbon. So in our practice in the US, where are we seeing the initiatives for embodied carbon reduction? Where are they coming from? I think, as many of you probably know, that we have these popular certification systems. LEED is probably the most extensive one used in the US. There are a few other programs that get used in terms of things like Living Building Challenge and the BREEAM system. These are, of course, voluntary rating systems that individual developers or government agencies decide to pursue for their projects. But these rating systems have all started to develop specific initiatives and credits that are associated with tracking and reducing embodied carbon, in addition to the credits that they've always had that were targeting reductions in operational energy and operational carbon. So we see a lot of activity happening in that realm. Also, in terms of the environmental social governance initiatives that many large corporations have undertaken, we are starting to find that many major companies, including those such as Amazon or Facebook or Salesforce, are also have created within their corporate policies that there are certain carbon reduction and embodied carbon reduction initiatives that they want to see happen in terms of their building stock. So on the voluntary side, we see that level of activity. It's also interesting on the right-hand side, and again, these are obviously all US and Western examples, but we are starting to see more legislative action starting to address issues related to embodied carbon. Sometimes they're very specific. So for instance, in New York State, where Dave and I do a lot of our work, they've started to create legislation for major emitting materials like concrete, where they are defining criteria for using low carbon concrete mixes that have to be used in state funded projects. Other cities and states within the US, well, they use this term buy clean, but essentially what they're talking about is also reduced embodied carbon, and they are also creating legislative requirements for state funded buildings. And what we're also starting to see, the last two bullet points, is just starting to see cities either in the US or Canada actually start to define limits for embodied carbon on a per square foot or per square meter basis. So that probably is going to be something that we see increasingly in the industry, where the designer, in the same way you might have an energy target, as Dave mentioned, in kilowatt hours per square foot or per square meter per year, you're going to have to start looking at embodied carbon limits that also have to be addressed and calculated. So in order to try to achieve these goals and to meet these targets, it is important to understand that there are tools and processes that are being developed to try to identify what the process should be or how one actually does measure these things in a consistent way. These are tools that we see, used in the US primarily, but I'm sure many of these are things that you have access to as well. There are a series of both a number of free publicly available tools that can be used, starting with things like basic documents like environmental product declarations. Some of these I will talk about actually in some of the slides I'm going to show after this. But there are some of these that are tools that are based on individual material analyses, and there are some of these that are based on actual whole building analyses. The more sophisticated tools, the ones to the right, like One-Click LCA or Tally, which is a direct plug-in into a Revit model, where you can actually, as you're designing the building, be creating a way to tabulate what the embodied carbon is of all the elements that you're including in the design. So I'm gonna talk a little bit about some of these tools to talk about how we tend to use these. So environmental product declarations are probably the sort of the kind of the baseline documents that I think a lot of these tools ultimately refer to. So for those of you who are not familiar with these are documents that are produced or reports that are produced by either manufacturers that are looking at very specific products that they produce and sell. In some cases, like the example you see here, several manufacturers that work on similar products. So in this case, tubular steel sections. There are several manufacturers that get together through a trade association, and they create what's known as an industry-wide environmental product declaration that covers basically, what the industry produces. What these reports generally provide are descriptions of the components that go into their products. They talk about what the process is, what's used to produce those products, to manufacture them. And ultimately, there are very specific rules about how they have to report this information, what they call product category rules. There are specific standards they have to meet. There are just guidelines about how long an EPD is considered to be valid for and what the scope is. But ultimately, I would say what most people are most interested in an EPD is at some point in the report, you'll see a table similar to this where you'll get the really nitty gritty, the actual numbers that you want to see about the life cycle impacts of producing that product at a specific, defined measurement. So in this case, they're talking about per 1 metric ton, the global warming potential and kilograms for CO2 per ton is therefore defined very specifically here. They are broken down if you recall that diagram I showed at the beginning of the various stages of the materials. This is only a part of the table, but this would go on into the other stages as well. But they do define for you very specifically what those impact factors are. And they also provide them not just for global warming, but for all these other areas for ozone depletion potential and eutrophication and various other factors, so that there really is a pretty complete assessment of what those environmental impacts of the product are. But these embodied carbon numbers really become the basis for how we start to work with some of the other tools that are available. And I'll start to show that as well. This is a graph that I'll just talk about quickly for the tool that's called the EC3, which is the Embodied Carbon in Construction Calculator. This is another tool that is becoming more popular in the United States for assessments of comparing different products. So what this tool basically does is they go out and they collect all of those environmental product declarations that are associated with a specific material. And then they start to provide a basis of how you see what that industry, what the variation is within that industry. So for instance, very quickly here, you'll see for this product type, which we haven't identified here, I think this might be some type of steel perhaps, but there's a maximum value that's shown for all of the EPDs that were associated with this product. There's a minimum. What they really try to focus on is what they call this box plot area, where they basically say, 80% of the EPDs are below this threshold, 20% of the EPDs are below this threshold. So this range tends to be where most of the products fall within, and it sort of starts to give you an idea of where the targets might be for embodied carbon for a specific product type. They also tend to define a baseline based on their assessment of that industry and what they think if you're going to make comparisons to that, this would be a common baseline for different designers or architects to use to compare their specific products to. And so this is kind of an additional way to do that analysis. So that box plot, in this case, this is for fiberglass insulation. Here's the overall box plot for all the fiberglass products that they had at that time, which was 25 different EPDs. On the right-hand side, you see individual manufacturers and their specific products and how those relate, the reporting numbers that they've provided compared to that overall box plot. And that allows designers, again, to start to understand where the opportunities are and which manufacturers are doing more aggressive work in reducing their carbon footprint of their products than others. And ultimately, this, I'm not going to go through this whole lot of words here, but this where the red box is, what we are starting to do in our practice, what we're starting to see happen is that in our specifications for different products, this case we're showing an example of gypsum wallboard that's used, for finishing different building types here in the U.S. That in addition to all the other information that will go into a specification about the performance characteristics of the product that's required and other factors that go into it, we're starting to see that certain clients are asking us to define for them an embodied carbon limit for those materials, so that we've done it. What will happen is that the project team will do an analysis. They'll decide what is an achievable number for a particular type of product. And then those numbers will be put into the specification so that if there are any opportunities or any examples during construction where a contractor might want to substitute a product from what may have been called for in the specification, they have to demonstrate that that product still meets these criteria. And that's a very new area within our industry, but we're starting to see this become a real part of a sustainable building specification. Now, I'm not going to I can't get from our time limits into too much detail, but some of the whole building analyses programs like the one-click LCAs, what I'm showing here, or the tally system that I mentioned earlier. When you're doing a whole building analysis, typically, depending on what program you're looking at, or like whether you're doing a LEED project or something like that, oftentimes the focus of those studies are either on the structure and the envelope materials within the building. Sometimes they can also include or focus on interior construction materials. But in either case, the main issue, these assessments or these programs are really doing a very detailed assessment where you actually will have to identify, in this case, I'm talking about an acoustical ceiling, which is part of an interior construction, but you'll have to go through and address the various quantities of all the materials. This is where having a BIM program is really helpful to define those material quantities. You'll see to the right-hand side that you can identify, again, using the EPDs, the very specific products that are actually used within the building, so that you're actually getting the embodied carbon numbers of those specific products. And essentially you build up all the components of the building that are part of your study until you can finally get an overall whole building type of assessment. And again, this table, probably a little difficult to see, but you can start to see that, again, we have those life cycle stages defined here from the A1 to A3, which are the construction of the materials, transportation. Sometimes some of these things are not included, like repair, but also end of life calculations. These software programs help you define all of those categories and come up with a summary at the end, so that at the end of the day, you're seeing what the entire building components are for global warming, and again for all these other similar environmental impacts. One interesting thing about this as well is when these softwares, typically what you do is you define a baseline and then you define your design case. And you can see with these green numbers here to the right, this number is saying this is the number for the design, and that number actually has reduced the embodied carbon by 37% compared to the baseline that was also defined in the software. So these types of skills, I think, are going to be very valuable in the industry. People who know how to use these softwares, who know how to do these analyses, are going to have a really important role to play in terms of assisting designers and others in making decisions. Of course, that information can be displayed graphically. This is just a very simple example of how you can start to see the impacts over the 6 impact categories between a base case and a design. Another interesting part of the analysis is to actually see what are the major material types that are impacting your building. Where is the embodied carbon included? And as you can see from this example of a U.S. based office building, that steel and concrete, as you might imagine, for the structural components of the building were 2 very high components. But in the U.S., where we do a lot of aluminum based curtain wall structures for our high-rise office buildings and things like that, the contribution of aluminum is actually very significant in the total of the building. And so starting to understand where those major factors are is an important part of understanding where the opportunities are. And then lastly, I just want to mention different ways in which having this ability to assess embodied carbon is being used in the design process. So this is one example where, again, we were using one-click LCA. We had a project that was starting to in the early stages of a new building, and the architect and the owner asked us, let's look at a few different wall assembly types, not based on the entire building yet, but based on just like looking at a common unit, let's say 1 square meter of an assembly. What's the difference between these different components? And you start to see that can actually be a fairly significant impact when you're just talking about different types of wall systems. And so that really can inform the design team very early in the process about deciding what actually really makes sense, and also comparing these kinds of embodied carbon factors to the operational impacts that those wall assemblies may have in terms of whether they have better or worse insulating properties than each other. Another skill set I think that people working in this industry will need to start to develop is actually understanding what are the initiatives that the manufacturers are offering to try to reduce the embodied carbon within the various material types. So this concrete is obviously one of the highest embodied carbon materials that get to be used. And so it's important to kind of understand what are the strategies that you can start to look at. Sometimes it's based on basic design decisions that are made that allow you to determine the use of material. And then within the materials themselves, what we start to see are there are various types of variations of Portland cement and other cement additives that can be used to reduce the embodied carbon of the concrete or the cement itself. Some of them are developing things like aggregates, which you see this picture of, that are being developed that actually capture CO2 and can potentially even provide a carbon negative impact to the overall concrete. So, and what we've tended to see is that, for instance, in this case, using 40% of things like fly ash or slag in a concrete slab versus a typical 20% can reduce, the carbon reduction of that concrete, in the range of 20 to 25%. And similar issues, in other material types, steel and aluminum. I mentioned those were the other 2 big materials. A lot of it depends on the type of process that's used to produce the steel. Electric arc furnaces, which are commonly used in the U.S., tend to be a lot cleaner than the old basic oxygen furnace process that's used for steel. And a big area that the industry needs to really catch up with is recycled content in aluminum. Aluminum curtain walls and architectural extrusions tend to be highly virgin-based materials and very high embodied carbon. But by adding even small percentages of recycled content to that, it can actually reduce significantly the embodied carbon of that material. And the manufacturers are just starting to realize that that's something that they need to start really looking into and being able to offer more options for that. And then finally, just a couple of other examples of how embodied carbon is being used in the way things that we do. This example up at the top we had an owner who was looking at building a new building, and they were looking at double pane glazing windows versus triple pane glazing windows. Now, typically that would be evaluated from an operational carbon and energy standpoint. You know, the triple pane glazing is going to be more efficient. In a northern climate, it's going to allow you to save a certain amount of energy. So that you'll see that impact. But then the other issue came up about, well, since a triple pane window obviously has more material in it, what is the carbon impact of the window itself? And what we found, is that, you know, in that case, the payback for this building looked to be pretty reasonable. You know, that from an embodied carbon standpoint, meaning that the amount of operational carbon that you save pays back for the additional carbon of making that higher material window within 2.5 to 4 years. So that was something that the client, you know, sort of gave them additional reason to invest in the triple pane window. The example at the bottom was in a way a little bit of an opposite scenario. We had an existing building where the owner was looking at adding an insulated cap over an existing mullion on the building, and the embodied carbon impact of that was about 10 years, which was not very favorable for them, given that this existing system probably only had a life of about 10 years before it would need to be replaced. So in that case, it doesn't always work out to be a positive, and that's one of the benefits of having that ability to do these types of analyses and make informed decisions. And then lastly, just a couple of examples of projects that we're currently working on. This is currently a building under construction for JP Morgan Chase in Midtown Manhattan. We've been doing a lot of embodied carbon assessment work for them. They have been using a lot of recycled glass pozzolan in terms of their concrete mixes for the floor systems. And so we're showing about a 12% reduction in the embodied carbon of those concrete materials, which is significant for them. On a much smaller scale, this is our own office in New York City for Socotec. In this case, we made a decision for an interior fit out to use a wood flooring material where we might normally have used carpet. The wood is a bit more expensive. It was an FSC certified, sustainably harvested material. But one of the other benefits you find from that is there's a significant carbon reduction between a wood floor and a carpet, you know, petroleum-based carpet material, and it actually made a significant difference in terms of reducing embodied carbon there. So that's my piece of the presentation. I know Dave mentioned he wanted to talk about those opportunities, so I'll stop sharing here, but I think either one of us would be happy to answer questions at this point as well. Dave, you're going to reload yours, right? Your slide.
Thank you so much, sir. If I may ask, Mr. Devashish, sir, you had some presentation to give. The last slide.
Are you able to see the screen now?
Yes, it
Yes.
is. Yes.
So thank you, John, for getting us through more of a teaching class on this embodied carbon. We have to study that hard, but you know, as you can hear, for the students, I would say it's a couple of the words are very important. That is, those tools, if you can bring up to speed yourselves, you know, they are very useful. And if this institute can offer some of those in their curriculum, in practical parts, and some of these, I'll just have few slides, and we don't have a lot of time, but we will come back very quickly to Q&A, question answer. So I produced 3 slides to just put some ideas out there. This is a discussion, and where can you find jobs in the career opportunities? You know, where in the theories you learn and what you practice in the field, it is no longer a whole lot different. You know, what buildings are built in Bangalore for LEED Platinum and what's being built here in the US, or John just had trips to Japan, Korea, and all kinds of places. We did work in Brazil. It's all universal. At the end of the day, it's relative to climate, it's relative to the comfort and productivity of who will occupy that building. And as long as we have that goal in front of us, that as individuals, as project managers, as supervisors, as engineers, whichever role you play, you focus on that low carbon or climate change sensitive construction and practices. So media, academic, government, agency, industry, I can just go through these are nothing new, but in general, these areas you can find jobs in most cases. Let me just go through some of these policy making that happens in the global stage, at the country stage, micro and macro, and at municipal level. We have various revisions of codes. I think BEE is very active on that area in India, and international code community is active throughout the world. There are penalties, there are efficiency related tolling, smart transportation coming in, carbon trading. A lot is happening. If you in this room are thinking that, did I choose the right area? I think it's a resounding yes as an answer. So corporations, most of these big fortune companies, the top companies operate worldwide. There is no more bar with the COVID, Zoom and Teams and all of that has connected the world so much, so fast, that you can find opportunities as a remote worker, you can find opportunity as a field person. We do work in Middle East, we do work in opposite side of globe. I'm sure many of you do the same. So be the part of the knowledge team of AEE, an excellent body of practitioners, and always try to excel. ISWBM has been at the forefront of the eastern side. We have, of course, there have been some regional issues, but within the constraints, try to focus on corporations. If you want corporation jobs, if you want corporations in the sense companies, if you want policy making jobs, and some of these example jobs you can find, throughout your search. It's and I just did a quick check, what we seek here locally, and I'm sure your areas would be very similar. Your interests will be very similar. So I'll just stop here and rather open and listen to what you have to say as the professors and the students, and we'll try to answer some questions.
Thank you so much, sir. First of all, good morning to you. And I would like to now ask BKC sir, our professor, to kindly say a few words.
Thank you, Sriyanshi. It is a proud privilege to be with these stalwarts. Actually, Mr. Dev Lahiri is one of our renowned international advisor. He has been advising since the formation of the E chapter. And I remember that his visits to IISWBM has always been enlightening and encouraging to the students. He gave the ASRE book maybe 20 years before to the library, and he conducted some seminars which now we have the fire and safety department, but before that when there was some fire and things going on, he conducted some seminars that how this is also very important for buildings safety. And now today we listen to these two stalwarts along with him, Mr. John. Actually, these topics that has been presented by them are extremely close to our syllabus, and of course there are some as Devda has pointed out, that the tools that are to be practiced and selectively incorporated depending on the market. As we know that there is a pull and push, so we have to work with the placement department as we do so, and we shall selectively find some of the tools that has been presented by John, because we see that they are extremely useful, handy, and informative, provided we get those data, lots of data. He has been showing that embodied energy, embodied carbon, and now he says about the carbon payback. So that is quite fascinating. We are practicing in syllabus. We have simple payback, energy payback, and now carbon payback. So definitely this will add some more food for thought for our upgradation of syllabus, which is a continuous process. Like we have the climate change mitigation, sustainability scenarios, building energy management, energy business models, which are upcoming areas, and we have incorporated also recently the sustainability issues in SMEs and designated consumers. As Devda was telling, that Bureau of Energy Efficiency in India has been very much proactive in certain areas in energy efficiency and building also. So designated consumers in India, their numbers are increasing. We have seen in class that how the different regulations have come up, and we are getting more and more designated consumers in India, and they are actually following all the rules and regulations. It is mandatory for them to implement the rules of Energy Conservation Act, which is also getting amended and upgraded regular manner. And we know that there are that energy conservation building codes, and this is we have the different this ECBC. Along with that, we have that Green Building Council, that Indian Green Building Council. We have the ratings, and in Kolkata we have number of buildings. We take the students to visit the gold and platinum rated buildings, and B has that 5-star rated malls in Calcutta. That was the India's first 5-star rated mall, that was in Calcutta. So we have been seeing that there is quite improvement and quite I would say dynamic scenario, and if we do not catch up with that motion, then we shall get lost in the background. So it is good that we have good number of alumni members who are also continuously in touch with us, and they are in the as Devda had pointed out, that they are in the forefront of energy sector, not only in this region but even globally. We have their presence, and that helps our students also to upgrade to get into the what is happening in India. Recently, we know that ESG, in this environmental, social, and governance reporting, has become mandatory for 1,000 top capital companies listed by SEBI, and this is also creating some market for energy management students. Along with that, environment impact assessment and whatever has been discussed today. And I am sure that the way they have been guiding us and they have been pointing out the topics, it will definitely should be carried forward, and we shall be open to them, and in the next available opportunity we shall implement them as we have been doing earlier also. So this is, and we have two more interesting things where probably we can get their help or guidance even because today that COVID has opened up this virtual world more, and that is how maybe 4 years, 5 years before such type of interactions was not thought of, what now we are regularly conducting. And so internship project work, which is 200 marks in in this curriculum, and 100 marks in dissertation. Both these are actually to implement what may not be exactly in the syllabus, but the demand, that is the pull of the market. So that we have to address those issues, and we have to find out that what is the real problem in the real job world, and try to solve. So get some pulse on of that, and we are happy to be associated in doing so with some of the leading companies as well as organizations. So earlier I remember that Devda had given the opportunity to our students for doing some though it is maybe a small work, but that helped the students to know the real life, that so that is what we look forward to you, and so that the students get ready, job ready, as they are going through this 2-year full-time MBA in energy management program under the University of Calcutta. So this university and our institute is ranked within 25 or 30 in India, and we look forward that we shall be able to not only maintain but also progress further through this opportunity that has been there, and you have rightly pointed out and made the topic so interesting. And so we are very much thankful and look forward for more such interactions and associations. Thank you. Sorry that my this photo is not coming. I tried, but something is happening in the camera. So, but anyway, so thank you again, and we shall be in touch. Over to Sriyangsi.
Thank you so much, sir. Now we'll be quickly moving towards the Q&A session. So the first question is from my side to Mr. Devashish. Sir, can you explain? You very well rightly said that control is a central part to the nervous system. So in this context, do you see transparency as a long-term approach for decarbonization or as a short-term approach?
Transparency is a very broad word. I mean, it is between various control systems, you ask, or is it between the policymakers? And I didn't understand the question, how transparency relates to controls.
So transparency with in effect to policies.
Oh, policies, I think John can answer something, you know, like we do have various agencies, and it is a little bit of political science than natural science, as you can imagine. And if you are watching news, you can always see that oftentimes it's divided by interests of individual nations or regions, and it's messy and complex situation. But John has some experience. I mean, I am with the New York State Energy Code updation advisory team, but for the green side, for the embodied energy, for the operational, more in the embodied energy, John has served in the U.S. Green Building Council. Am I right?
I've done some teaching for them and some advisory work. I mean, I think what I would say with transparency is it's still mostly on the operational side, right? I mean, like Dave was mentioning, like in places that in the US now, we're starting to see more and more requirements for building owners, right, to publish their and report their actual operational energy use and carbon emissions as part of the basis for how the city establishes their targets. I'd say embodied carbon is not there yet in terms of seeing that being a requirement for people to report on. But I think my general sense is that that level of transparency is a good motivator because it taps into the competitive nature, right? That people will say, oh, this building is performing better than another one. And if you're the one who's got the lower performing building, it gives you more motivation to do something about it, right? Once that information is transparent to the users and others.
Yeah, you're absolutely right, John. I mean, Sriyangsi, I'm sorry. It is, if you walk in the streets of New York, you will see every building has a letter grade and about 8.5, 11, like something pretty large, A, B, or C, or F for fail. So it is transparent. And as you enter a restaurant, there is also food grade, A, B, C. So people try always to keep their restaurants in top shape that you come in to eat there. So buildings, as John said, it creates a healthy competition to make your building cleaner, greener, and more attractive to the future clients, which are the students who are sitting in this room. They will be practicing for the next 30 years. So yes, it is important. It's happening. Right now, I think the LEED Gold Platinum rating is restricted to the bigger buildings, the fancier buildings, but it will percolate down, in my opinion.
Thank you so much, sir, for your answer. So the next question is, after impact analysis, how the materials can be modified for efficiency?
That's John's directive.
Well, can you repeat the question, please? I'm sorry, I didn't quite hear it. Can you repeat the question, please?
Definitely, sir. So it goes like, after impact analysis, how the materials can be modified for efficiency.
Yeah, I think what we're finding is that what's happening is that people are starting to understand which materials have the most impact and what it takes to achieve a building-wide goal. For instance, as you may be familiar with, like a program like LEED will say, okay, if you can achieve a 5% reduction or a 10% reduction in the embodied carbon of your building, those are the thresholds they've established for achievement. So for project teams to understand what does it take to achieve those, we're spending a lot of time doing the analysis to understand the impact of what the components contribute towards that. And then what we're really doing is having to reach out to manufacturers and to do research on what the alternatives are. As I mentioned, sometimes there are some opportunities that can be done in terms of basic structural efficiencies or design-based efficiencies that can reduce the use of certain products, and therefore you can get some reductions based on a direct basis of that nature. But there's also a lot of work that's being done to establish what programs or what products are out there that are better. And it's really, again, in the same kind of nature of that the competitive nature. We're starting to see that a lot of the manufacturers are starting to promote the fact that they do offer some lower carbon alternative products. I mentioned earlier in the example of our office renovation that we used a very extensive area of wood flooring instead of carpet, which would be more traditional in a New York-based office building. But interestingly enough, the carpet manufacturers in the U.S. now are working towards some very significant opportunities to use bio-based materials and other types of fillers that capture made from concrete capturing materials or CO2 capturing materials that can really reduce the impact of their products significantly. Cut the embodied carbon by more than half compared to some other standards in the industry. So I think that's really where we're starting to see the activities, and I expect that more manufacturers are going to be able to provide more options for us and as time goes on.
Thank you so much for your answer, sir. So the next question is again to you. From existing building perspective, can we do life cycle assessment of cradle to cradle, or do we limit it to gate to gate?
If I'm understanding the question correctly, I can just repeat it for you. So it goes like, from the existing building perspective, can we use LCA from cradle to cradle, or do we just limit it to gate approach? Yeah, I think what for existing buildings is probably more gate to gate, but I actually have to say what we've been asked to do in relation to existing buildings. To some extent, right, in existing building, the carbon impact of that building is already in the atmosphere, right? It's I think they typically say that, from what I've read, that the carbon impacts, the carbon emissions, are in the atmosphere from, let's say an average of 200 years. So if you've done a building that's, less than that amount of time period, those carbon emissions are in the atmosphere. So what we have been asked to do for a certain number of projects, including for the United Nations project, the headquarters in New York City, they asked us to evaluate what was the quantity of carbon emissions that was avoided by not demolishing that facility and building a new facility. That was done a few years ago, because if you're aware that the United Nations undertook a major renovation, the biggest renovation they had ever done since their initial construction of the facility back in the in the 1940s and 50s. So they wanted to understand, not that they intended to do this, but had they decided to demolish the campus and build a new campus that might have been more energy efficient than the renovation, would that have made more sense if you looked at what the embodied carbon impacts were? And interestingly enough, our conclusion was, what we looked at then, therefore, was to calculate embodied carbon for essentially the same size buildings using modern, sort of construction materials, but similar to what was done, concrete and steel. And we came to the conclusion that that unless they had done something really radical, which was not something that was part of the assessment, if they'd used more traditional, energy efficiency measures and things, it would still probably have taken at least 35 and possibly up to 70 years for them to recoup the embodied carbon of building a new facility compared to the additional energy savings that they might have achieved by building a brand new facility. I'm not sure if I'm very clear on that, but basically what they were saying.
John, if I may come in, I asked
Sure.
this question. My name is Shivaji. I'm an ex-alumni of ISWBM and an AWE member as well, and I'm joining in from Saudi Arabia. I am the MNV head at Tashid, the Super ESCO of Saudi Arabia.
So given the background of my job, we do assess building and we do the energy efficiency side of the building heavily here over the last 5 years. And you might be knowing this as well and hearing the progress and the progression of how building energy efficiency is being done in this part of the Middle East. Now, as I say this, the challenge and why I asked this question specifically, and this is a very interesting conversation, and I've been fully engrossed in it. And thank you very much to both you and Dave for the great presentations. My question here was more related to the fact that when we are dealing with buildings, it's typically a 40 to 45-year-old buildings, because these are all fed by chiller or chiller plants, which are being built up from the US manufacturers of chillers like Carrier and all. And in order to account for the, from the accountability of the product carbon from the extent of 40, 50 years old products which have been used, and from a cradle perspective, it's been quite difficult. Whereas when it comes to new properties or buildings, as you must be knowing, NEOM is building up all the new facilities here in Saudi Arabia where they are accounting for the life cycle. LCA is a basic minimum requirement which comes into picture, and they're accounting from the cradle at this stage, which is the construction phase of those buildings. So these are new construction that I'm talking about from NEOM perspective, as compared to the existing buildings on which we as a mandate work for the energy efficiency. So if we account for the entire life cycle, it's really challenging. And that's why I asked this question. Probably the second question is also linked to this. So over back to you.
I mean, I think, I mean, I can imagine what you're saying in terms of the complexity of trying to address for the existing building. And I have to say that from our experience, we just have not had that level of request to try to understand if there's a way to calculate for older buildings and processes that were in place when those facilities were originally constructed. So all I can say is that the if you will, the placeholder that we've been working with when those questions are asked has to do with looking at new construction comparisons and trying to use that as a approximation of what you might have considered for the embodied carbon of the original structure when it was produced, with possibly some modification factors included, since most current materials are made more efficiently in many respects than older materials. But I don't have, unfortunately, I don't have a solution of how we might have attacked that particular problem.
Sure, thanks, John.
Sure.
Thank you so much, sir. There's a second part to it, which is, are there any tools which are available to account Scope 3 for the old or the existing buildings?
I think John already answered that, so you may ignore
Yeah.
that.
I have not found it. I mean, the only thing that the only thing I've ever seen sometimes is if in some of the very older textbooks, there were approximations that were made for embodied energy back in, like if you find there's some textbooks back from, let's say, the 1970s that have some data that we've looked at in the past. But I'm not sure that it's at a level of scrutiny that would be comparable to what we do today.
John, nothing of this sort in this part of the world, or not in India as well, I believe, can be most likely found in US, but not in this part of the world. We are fairly new to this culture as we educate people in the mass here for awareness more on these aspects, and to dig in to that extent. I mean, basic SLDs are sometimes a challenge. So the rest of it is out of question.
Understood.
So the next question is, in steel structure, how heat management can be improved by materials, and how energy management can improve?
In steel structures?
Yes, sir.
I think I can answer a part of it, that steel structures are common in certain parts of US. I think RCC or concrete is more prevalent in India from my personal experience, but others can probably know better. In steel structures, we have the ability to analyze the thermal bridging in cold climate. We have various tools. So energy management practice in making sure your jacket, which I'm wearing here, is proper. Your jacket has to be, the building enclosure or the envelope is given a lot of priority in terms of making the space, the conditioned space, more efficient, so that the steel does not transmit the heat or cold out. And that's the only part I can comment. I don't have structural experience. I'm not a structural engineer. So relative to steel, John has probably shown you the numbers of existing plants with arc furnaces instead of the Bessemer converter above BOF furnace. And the energy management, yes, we will definitely focus on steel as the proper handling of the steel with various tools such as 3D energy model or finite element model. Those, for students, they are important to learn. If you have ability to learn heat transfer, I'm not sure, this is the MBA school, so maybe less engineering, but those are useful tools. And that's how we try to make the jacket, the envelope, tight enough, smart enough, and less conductive in cold climates. In warm climates, it's a little different thing, vapor barrier and transmission of the heat from outside, just like Shivaji was saying in Saudi Arabia. I worked in Abu Dhabi. We built some large hotels, and if you are aware, Cleveland Clinic, there are fantastic properties as in Dubai and Abu Dhabi. They make it tight. They are blower door tests done. I don't know if that's done in Saudi, but the envelope.
Yes, they do. Yes, they do. Here in Saudi as well, building envelope is a very important factor, Dave. I mean, building envelope is the scope, is the next level of things that we are focusing on as well, because the leakage is huge. I mean, not only from the green building perspective, also from the perspective of the heat percolation over the facades. So facade and the air balancing of the building has become the need of the hour. So much to do, so much to save, but the focus area still remains unstressed.
Yes. So for steel, answering the question, yes, in colder climates, we are very focused on those thermal bridging because it creates condensation, and condensation creates other headaches down the stream because it will now create mold. In cooler climates, not cold climates, but cooler climates, and the vapor barrier is an important piece. And actually in the new ASHRAE or even any codes, you will see the thermal envelope being given. As we make these envelopes more engineered, it's no longer just brick and block or brick and cement, the traditional way we built 30, 40, 50 years back. That's no longer the case. Now you have to add insulation, you have to add fascia, you have to add a lot of glass, and the air balancing in larger buildings, the stack effect come into play. We are also in the middle of it, scratching our heads, just like Shivaji was saying. I'm sure he is into some of these taller buildings, that has a different set of headaches. But I'll stop here.
Thank you so much, sir. So the next question is, what is supplemental cementitious material?
Yeah, sorry if I wasn't clear on that. So it's, in a typical concrete mix, as most of you probably know, you've got cement, primarily cement, sand, aggregate, and then other additives. And the portion of the concrete mix that's actually cement is relatively small. Maybe I'm going to say in the range of less than 10% typically. But of that cement, in the U.S. certainly, and I think in most places, well, we use what we call Portland cement, right? That's the typical cement material that has a very high embodied carbon profile, not just because of the process to make it, which involves a lot of heating of limestone materials, but also the actual calcification process emits emissions as well. So supplementary cementitious materials are things like fly ash, which in the U.S. is typically, coming from as a waste product from coal-fired power plants. There's what they call ground granulated slag, which is coming typically from steel production as a waste product. I mentioned for our project with JP Morgan Chase in New York, there are actual products now being made from recycled glass that's ground into a very fine powder. Essentially, those are all called supplementary cementitious materials because what they do is they replace the Portland cement in the concrete mix. So when you're reducing the amount of that high embodied carbon Portland cement and replacing it with these products, which again are mostly waste products from other industries that have a much, much lower embodied carbon factor for those materials. And so that's how you end up reducing the overall embodied carbon of the cement and then of the concrete mix.
Thank you so much for your answer. So there's a last question. Should we go by ISO, that is Indian Standard 14040 guidelines, or refer to any other tool for LC?
There are, I think that is the typical standard that we use. I have to be quite honest that there are several different numbers that we see show up with things like EPDs and other processes. We typically go by those basic. I believe that's the same standard that we typically refer to when doing looking at the LCA softwares and what the basis is of how they're being done and the analyses that come into the EPDs as well. So I can't say as a practitioner, I can't say that I am well researched into what alternatives might be to those. So right now, I think as a practitioner, we are mostly focusing on making sure that the information we get from different manufacturers and how the softwares are working, meet these industry standards so that we can demonstrate there's a consistency in how the models are being run. And I will say that's, what maybe not exactly what's being asked for here, but one of the critical issues I'd say in the embodied carbon industry right now is that establishing a consistent baseline for projects that you can then compare to so that you can demonstrate what the savings is that you've achieved is still, I would say, a bit of an emerging area. It's probably like Dave would say the industry was at with energy modeling for operational carbon and energy, maybe 20 years ago, where again, it was people were doing baselines and compared to their designs in different ways. And so they'd end up with different results. So that level of consistency is something that in the embodied carbon area is being worked on actively by different sectors of the industry, but it's still a little bit not totally codified yet.
John, again, this came from me. Sorry to bring back up on this. And my question was basically linked to the fact that my first LCA was way back, maybe 18 years back, when we used to do PAS 2040, 2050 as the tool to do. And Excel was the only source of, resource that we had. And Dave is smiling as I say this. So, and it was glass industry. So, and as far as I remember, nothing beyond that was what in the middle articulation for many years until very recently in 2018, I was in 2016 when I was in Dubai with SGS in the Gulf, and somebody requested me a testing of a material under EPD, and I was frantically looking for someone to do a test of a building material. So I was pretty much concerned, okay, what really is the guideline and the tool on this? Because this does not happen outrightly that you go for a testing of a material from a certification company and ask for it. And at that juncture, I was stuck and I could not figure out. I still don't have an answer to this because obviously I feel like being a layman as well. And yes, certain sector specific tools and guidelines have surely come, as you said, and being a sustainability expert myself for over now 2 decades, this has been the bread and butter. We have been trying to dig in, have been involved with SABIC into their sustainability and with Tashni in implementing it, and with petrochemicals being done by Buruj as one of the pioneers in this region. We follow their benchmarks. So benchmarking, again, guidelines and tools, and this, there are a lot of progression on certain aspects from regional perspective, which is absent on various sectoral specific base, I would say, and to refer back to the baselines, it's very difficult. I mean, I would rest my case here because we have limited resources and we all are working towards it as of now.
I agreed. I think we've all identified the issues and that need to be worked on, but it's a bit of a slow process, as we know.
Thank you so much, sir. Now we would like to officially close this session up. Thank you for making this session a more informative and much more detailed. And now I would like to request BKC sir to kindly give the vote of thanks.
So again, we are actually overshooting by almost 36 minutes. So it is a formal vote of thanks. I don't think actually we have enough words to express our gratitude to the honorable speakers, and also Shivaji came up in the stage. So thank you, Shivaji, also. And also the dear students who have taken lots of pain and conducted this event so nicely. And I hope that this will continue in a very interesting and more profound way, I would say. Thank you all for being here.
Thank you for having us.
Thank you.